Okay, we have a lot to get done today. And sadly, we got to start off with some hard workshops. Okay, before we start all of that, you might as well, other people have used calculators since you might as well press on, press y equals, and clear out whatever they've done. Okay, as for our math workshops, the first one wants us to solve this equation by factoring. First things first, let's focus on, is there a GCF? What is the GCF? We could pull out, ignore the equals 0. Is there something we could pull out? We can bring out some x's, and I'm hoping there's something else. Yes. Who said 3? Okay, 6 can have the point. So Seth and 6 can have the point. 1 and 6, sorry. Okay, so if we bring out a 3 and an x squared, we would be left with what? X to the what power? We add the exponent, so it needs to be x to the what power? Yeah, because 4 plus 2 is 6. And then minus 13 x to the... Yes, and then plus what?
36.
36. And is there an x? No. Okay, so 2 and 6 can have a point. Okay, after that, it said solve by factoring. If we were to pretend, and we're just pretending right now, so I'm going to write a pretend thing. If this was instead, if we could change this problem to x squared minus 13x plus 36, could we factor that? Could we factor this? This new blue problem I'm writing over here. Can we factor it? So I need two things that add to negative 13 and multiply to 36. Now I can think of one. Yes.
9.
And
No.
9 times what is 36? 4. 9 and 4. And 9, 10, 11, 12, 13. So 9 and 4. So x minus 9, you can have your point. X minus 4. Okay, but you're like, but Miss Compton, what you wrote in blue is not what our problem is. No, it's not. But, if I bring down that 3x squared, I'm going to leave that equals 0 as it is. Really, x to the 4th, we could say that's x squared times x squared. And then I'll still put Seth's minus 9 and his minus 4. And if you're questioning me, let's FOIL it out really fast in our head. X to the 4th minus 4x squared minus 9x squared. Well, that's minus 13x squared. And then negative 9 times negative 4 is positive 36. So this is correct. So x squared times x squared is going to be x to the 4th. I broke up the x to the 4th into 2 x squareds. And then I'm checking myself, and when I FOIL it out, it does end up being that thing in red. No, that's a good question. And so these math workshops are actually a little ahead of where we're going to be in life. So we'll have to save, for sure we have to save 18 for tomorrow. We won't save 17. I'll go ahead and spoil the end of the plot line for you. But, so it said not just factor, but it said solve. And one reason we knew we were going to have to do a little more than just this is because of that solve word, and also because of the equals 0. Anytime you see an equal sign, they actually want like a set answer. Our answer is this. So we're actually going to take each piece and set it equal to 0. So I'm going to set 3x squared equal to 0. I'm going to set x squared minus 9 equal to 0. And I'm going to set x squared minus 4 equal to 0. And again, I swear I'm ahead of where we are. This math workshop is ahead of where we are in our notes. We will get here. We're just going to fake it till we make it today. So if I want to solve this first equation, I want just x equals some number. What do I do first? By what? Okay, 3 is the point. So if I divide by 3, I'll have x squared equals 0. How do I get rid of the squared? Yes, Kelsey. Were you not the one who said it? It was you? We take the square root, yes, so you get the point 3, so x equals 0. We take the square root of both sides. Square root of 0 is still just 0, so x equals 0. So one of our answers is x equals 0. But as you can tell, we're actually going to have a couple answers. You would say 3, but you'll be surprised. Okay, so same thoughts on the next equation. I add 9, so x squared equals 9. I take the square root of both sides, so I get x equals what number? You'll want to say that, don't you? I mean, it is 3, but it's also another number. What else squared is 9? Well, I get 3 squared is 9, but what else squared is 9? You're overthinking your life. Negative 3. Negative 3 times negative 3 is positive 9. So technically we have 2 answers from this option. It could be positive 3 or it could be negative 3. Ma'am, go for it.
What I did, because you got x squared minus 9, that's the difference of 2 squares. So you split that,
Oh.
x plus 3 and x minus 3, and then you can put those.
Okay, so Miss Brewster makes it even easier to understand. She said x squared minus 9. She actually recognized 9 is a perfect square. So she said x plus 3, x minus 3, and then set each of those equal to 0. So x plus 3 equals 0, x equals negative 3. X minus 3 equals 0, x equals positive 3. And now you have a better reason as to why it's both, other than Miss Compton just telling you so.
And you do it the same way.
So let's do it the same way on the next one. Instead of x squared minus 4 equals 0, can we not factor that better?
Yes.
To what? Yes, so let's do x plus 2 and x minus 2. I heard it from 1 and 3. They get the point. So my 2 answers for this one are going to be what? And? Yeah, so I'm going to end up having plus or minus 2 again, because I do x plus 2 equals 0, so x equals negative 2. And I do x minus 2 equals 0, so x equals positive 2. That's completely correct. Now, if you're like me and you realized, hey, it's going to be the plus or minus to begin with, that's great. But Brewster's completely 100% correct. Haven't we been practicing recognizing the difference of squares to begin with? And then she recognized it faster than I did. I would give her group a point, but sadly, she can. Her own special group can have their own special number slip, and she can have all the points. Okay, we will save 18 for tomorrow because it, like 17, is a pain. It requires knowledge that we have not quite gained yet. Let's go back to our notes. Yesterday we only did 2 problems, right? So we're starting on number 3. So to recap, we got a little behind. Not a big deal. We're fixing it by getting to use our graphing calculators way sooner than other people do. And we're also being kind of lazy. So the directions said we were supposed to sketch a picture of the graph. We're not doing that. The directions also said that we were supposed to, or something else they said, make a table of values. We're not doing that either. So all we're doing is that list we made yesterday. We want to know from this function, this quadratic function, we want to know the y-intercept, the vertex, the axis of symmetry, we want to know if it's a min or a max. And then we want to know the domain and the range. Seth is right. It is going to be a min, so his group can have a point for that. There's something else you can always tell. If it's a positive number in front, it's going to be a min. If it's a negative number in front, it's going to be a max every single time. Absolutely. There's also something else you can tell without actually graphing this problem. I know where the y-intercept is. Do you know where the y-intercept is for a point?
Yes.
And 6 said it first, so we'll give it to them. So it's at 0, 5. Okay, but there's something else we should always guess, because I'm telling you 90...
Teacher, students, excuse the interruption. At this time, I need all students who are participating in the computer science field trip to UAB to report to the bus canopy at this time. Students going on the UAB field trip for computer science, please report to the bus canopy at this time. Thank you.
Is it like a thing that you have to say it double, like saying it once isn't enough? I don't know.
You have to be redundant.
Yeah, apparently, I don't know. And normally it's 3s, but whatever. Okay, domain is the other thing you're supposed to automatically know, and it is Yeah, I know I heard it from 4 and from 3. Did anyone else say it and want to claim it? 6. Seriously, unless we do a real world problem that somehow restricts the domain, every single time you better put negative infinity, infinity, because it's always true for a regular old quadratic. Okay, so we've already filled in 3 of like the 6 things we needed to know, and we still haven't even graphed it. That's what's crazy. Okay, so let's go ahead and graph this bad boy on our calculator. So press y equals, we do 2x squared minus 8x plus 5, and then you press graph. And if you're like me, my zoom is weird. Someone's been messing with my calculator, my zoom is weird. So I'm going to say zoom standard or zoom fit. Try to see if it looks a little prettier. It did. Zoom fit, zoom standard looks pretty good today. Okay, is there anyone who can get to here? Okay, if you're having issues, don't forget to use, when it's 2x squared minus 8x, you do get to use the big minus sign. Okay, so we've graphed it, and if we wanted to check to make sure that intercept really is where we said it was at 5, we can. So we can press trace, and yes, it is at 0.5 to confirm it. We could also look at that table as discussed yesterday, so second table. Set this right, we have a min, so we're looking for the smallest number possible. So we might scroll both ways on our table and try to figure out what is the smallest number we see in that second column. What is the smallest number we see in that second column? The smallest number we see in that second. -3. So, one gets the point. So, what does that mean? I get that means our min is at -3. We normally just put the y value. Yesterday I said it was okay if you put both, but to be honest, we normally just put the y. But if Hal puts 2, -3, I'm not going to count off. I normally just put just the y, but if you want to put both, I'm not going to be mad. Or, I'll put or in between. But we also know 2 -3 is what? So we've got this parabola, and we know that this bottom happens at 2 -3, but what else? What is that bottom? What point is that? It's the vertex. So we know the vertex as well. I pretty much gave that one to you, so I'm going to keep it to myself. The axis of symmetry, we know that as well now too. What is the axis of symmetry? Well, the axis of symmetry is just one of those numbers. Is it the 2 or the -3? It's the 2. Okay, so what's really cool, and I guess I didn't explain it well yesterday, and I'll try to do better today. If we know that vertex, the first number is the axis of symmetry. The second number tells us the min or max. And then, to be honest, the second number kind of tells us about that range. So I already know. I mean, I can go back to my graph, and you can't do this, but I can because I own them. We can try to figure out when did it start touching, and it started touching at -3. So that min is the first time we touched it. So our range is -3 to infinity. So seriously, once we know the vertex, we know the vertex, the axis of symmetry, the min, and the range. So everything that we didn't fill in, we can now fill in. Okay, before we do the next one, there is one more cool trick I did not get to show you yesterday that you may or may not be interested in. As discussed, second table sometimes lets you down because that table's only counting by ones. Now, we talked about how to go to table set and change it to count by like halves or 0.1 or make it count differently in case you have a decimal. But even that's not going to give us an exact approximation. So if you're wanting to know, especially if it's a decimal answer, where exactly that min or whatever happens, there's one button we didn't get to press in yellow. So we press table, we press table set. We talked about why you never get to use stat plot and how no one messes with format. But we're going to mess with calculate. So if you press second calculate, you can actually do all the stuff that the table gives us from second calculate. So for instance, if I want to know the value at 0, which we already knew it was 5, but it told us that too. You can also ask it where a specific 0 happens, which we'll come back to later. But more importantly, Seth recognized this as a min, so we're going to press the min button. Now, the only problem with second calculate is that it requires a little more patience than a table of values. Yes, dear? Did you press second and then calc?
No, I mean like the graph itself. Like, I've been trying to press popular. It's not working.
Okay, so you understand, if I could write on this, I would. You understand the axis of symmetry is cutting down the middle, that's why it's 2. You understand the bottom, that vertex is 2, -3. And since it's the very bottom, that's the min. And then where it's crossing the y-axis, that's the y-intercept, it's at 5. Eventually we're going to talk about where it's crossing the x, so that's not even our deal today. What else are you mad at about it?
So you said, what, -3, you got from where, like in the range?
Yes, so I pressed second table and figured it out looking at my table. Because I knew since it was a min, I was looking for the smallest number in that second column. So if it was a max, I'd be looking for the largest number in that second column. But the issue is, so it's perfect for this one because it did end up being a whole number. But what I'm addressing is, what if it was a decimal? What if it was at 3.2 or -5.7? Then what will we do? So if you're wanting to guarantee you always have the right answer, instead of using the table, press second and calc. If you press second calc and then choose min, it requires a little more work than the table, but it can still tell you where that bottom's happening. Okay, but here's the part that stinks. So you and I both know, because we can see it with our eyes, that it only has one min. So why on earth are they wanting us to set a left bound? Well, it could be some weirdo like W that has a couple mins. There are other kinds of functions besides quadratics. The calculator's built to handle anything. So it's going to ask you this even though it's redundant. Okay, so when it says left bound, we have to tell it. So we know this is the bottom. We have to hit, you see that little monster thing lining up? We have to hit it a little to the left of where that bottom is. So wherever your cursor is, press enter. And it's hard to see, but now it's put a little arrow to let me know, hey, that's where you pressed enter. And now it wants to know the right bound, so you can take your monster and roll him around. Well, clearly now you want the monster to be on the right side of where you think that bottom is. So you can go on forever, you can stop right here, it doesn't matter. Press enter again. And it tells you, like, hey, you're saying that that bottom, that minimum, happens somewhere between here and here. That's what those arrows represent. And then they make you guess. I could redo calculators the way, we wish we could redo our phones. I would get rid of the guess, because the calculator's going to fix it the second we guess. Now, I know this is a bad guess, but you don't have to make a good guess. The calculator's going to tell you the real answer, whether you make a good guess or bad guess. I get that where my monster is not the minimum at this time, but, whatever. And then it for real tells you. The minimum is actually 1.99, so yes, we would round to 2, and -3. But if it ended up being a decimal...
Mine says 2.0.
Really? That's cool. Yeah, so our calculator's on rounding error. That's cool. But really, if it was a weirdo decimal, like 3.7, 3.8, it would show up here, whereas figuring that out from our table, not so much. So, I'm a math teacher, so we've purposely picked some of these problems. You'll eventually know, like, we'll point out, hey, I couldn't factor this, therefore I probably should be worried it's going to be some weirdo answers. But anyway, so I know you may not ever use second calculator.
Miss Compton?
Yes, ma'am.
Hey, I was going to remind you to post attendance.
Yes, ma'am.
Thank you.
Okay. So you type in number 4 while I post my attendance, because that is important. Okay, I'm back. We're going to do this last one, and then we're going to stop. And you're going to get to work on your stuff in life. Again, we're going to skip some steps. We're not actually going to graph a picture. We're not actually going to make a table of values. We're going to keep on sticking to this same list. I want to know the y-intercept, the vertex, the axis of symmetry. We want to know min or max, and he's right, it is a max, and you can have a point for that. We want to know the domain and the range. If it's a negative sign in front, it's going to end up being like a mountain, so you know it's a max. If it's a positive number in front, the way the previous one was a 2, it's always going to be like a valley, so you know it's a min. I don't know how he caught on that fast. That was very smart of him. Okay, there are some other things you can help me fill in before I graph it myself.
Y-intercept is 12.
The y-intercept is at -12. So I probably want to put 0, negative 12. Perfect, you can have a point for that. What's the other thing I want to fill in? Which is? Okay, 1 and 6. And then you tell me some of the rest. What's the vertex? What's the vertex? When you graphed it, did it show up on yours? So if it didn't show up on yours either, I'm having to do zoom fit to see if it'll show up on mine. Because a normal 10 by 10 was just not enough. When you press zoom fit, it should go. If it didn't, did you do the tiny negative sign? Okay, so since Seth said it was max, I'm looking at my table to figure out where is that highest value. I'm looking for the largest number possible. It looks like we're going up, bigger and bigger negatives. Oh, goodness. Yeah, the biggest I see is 0, negative 12. So, yes, I did zoom fit to make it show, because when you did zoom standard, because that intercepts at negative 12, it's not showing anything. So what's crazy is, what's crazy about this graph? Yes, and one was getting it out first, so he's getting at the point. The y-intercepts and the vertex are at the same spot, meaning so the top of our parabola, good Lord, get the words out, Miss Compton, also happens to be the axis of symmetry, also happens to be the y-axis. It happens to be all the things. That's crazy. So, yes, 0, negative 12 is our vertex. What does that make our axis of symmetry? No. Yes. What does that make our max? Yes, we're going for the y value, so negative 12. And then our range, well, yeah, it goes on until negative 12, but I'm going to say, if I'm looking at my picture, it went on forever down here, and then it eventually stopped, and apparently where it stops is at negative 12. So it's negative infinity, comma, negative 12. Dear? Yes, dear. Okay, are there any major questions about this? Okay, I've got two. Let me stop my recording before I ask the questions I'm going to dare ask and incriminate you all.